minus 270 degrees, and let's say minus 360 degrees. So it will be like this. Sine graph will be like this. Passing through this minus this and going through this to this point and moving this way, moving this way. Remember that the maximum it will eat is on the, this is just a rough sketch. It should be noted that this is just a rough, this is where the curve, where it cuts. So that's at a point minus 1, that is where it cuts, and it will go through 0 this way, do the origin, and to 1, to the point of 1, and cuts and pass through this, and goes this way, like this. Remember that the maximum, where the curve curves, is ranging from minus 1 and 1. That is it. It cannot go, the curve cannot exceed, this curve will definitely lie between minus 1 and 1. It should be noted that, and that is a typical example of a sine graph, where the maximum is 1 and the minimum will definitely be minus 1. So this is a typical example of a sine graph in trigonometry. So we can see some examples to justify our claim. It should be noted that the sine graph, the cosine graph, and the time graph we shall consider. Having talked about the sine graph, we are to talk about the cosine graph, and after the cosine graph we'll talk about the tan graph. But what's my interest here is to let you know the picture of how a sine graph looks, how a cosine graph looks, and how a tangent graph looks. So after that, we will now plot the sine graph against the respective theta using our graph. So the interest here is just to show you how it looks like, and having done that of sine graph, so our interest now is to talk about cosine, so that when you see a sine graph that is represented, you can be sure that this, because of the way this looks, then this must definitely be a sine graph. So in the case of a cosine graph, if you have a situation like this, you have a scenario like this, where you have, this is your 0, 0, 0 origin, 90 degrees, you have your 180, you have your 270, you have your 360. Going on the negative 2, you have a minus 90, you have your minus 180 degrees, you have your minus 270 degrees, and you have your minus 360 degrees. This is your x-axis. This is your x-axis, and this is definitely your y. Your y-axis. This is negative y, and this is positive y. So the maximum you have here is 1, and the maximum you have here is minus 1. Take note of that. But the difference between these is that a cosine graph cuts, is the sine graph cuts the vertical axis at the horizontal axis at minus 180 and 80, which was demonstrated earlier. Now this one will cut the horizontal axis at minus 270 and plus 270. So automatically what we will have is a scenario like this. The maximum value of our it will not exceed the minus 1. That is what we must put into consideration. And it will go this way. Remember that that of the sign passes through the origin directly. So in this case now, you see where this is passing. Then it goes this way. It goes this way towards this. And without passing through, without exceeding the negative, I also move this way. So the sine is of this form, while the cosine is of this form. So that is what we've been able to deduce from here. So this is a typical example of a cosine graph. This is a sketch, though we are still going to do it, plot it on a graph so that you can appreciate it better. So this is a typical example of a cosine graph. Remember that you still have a curve ranging between -1 and 1. So they can't exceed this. So this is a graph of tangents. X tan x. This is a typical graph. And what we can interpret from this graph is simply that the graph terminates at this point. The graph terminates. That is why if you take tan of 90 degrees, you will not have a real value. So that means it's coming from here, it terminates at this point, and it starts all over from here again, and it terminates at this point. Then starting all over again. Unlike the case, what you can deduce from here is the case of sine. You have a continuous scenario like this. In the case of, this is a sine x, for example. In the case of cosine, you have a situation like this, cos x. But in the case of tan x, you have it terminating. It continues, you have it terminating again, and that's like that. So that is these are the pictures of sine graph, cosine graph, and tan graph. When you see a scenario like this, you know that it's definitely talking about a sine graph. And when you see a scenario like this, it's definitely talking about cosine graph. And when you see a scenario like this, it's talking about a tan graph. So we are going to see some examples where we can plot this situation that we have on our graph. So let's see examples to justify the sine graph, the cosine graph, most especially. Now, these are the two examples to justify the sine graph and the cosine graph. In the first situation, the values have been given to us, so we need not pass through rigor of finding out the value. But the second situation, in this situation, we need to figure out, we construct a tables of values that we are going to use to plot the graph. And how can that be done? That can be done simply by trying to prepare a table of value for this. We have theta against our y. So this is what we're going to have. So now we resolve this. For the first case, we have minus 180 is the maximum. Then we use 45 degrees differences. So this minus this, we have minus 135 degrees. Then the next one will be minus 90 degrees. The next one will be minus 45 degrees. And the next one will be 0. So this one will be 0. And the next one will now be 45. The next one will be 90. The next one will be 135. And the last one will now be 180. So this will be our tables of values for this. So our y, the y function has been given the question to be, this is our y. So now, this is our y. So automatically, here if you have to calculate this, then we'll have sine minus 180 times 2. So we have to look for our y. So we can just make our y the last here. Then we write 2 sine theta. Then we write 3 cos theta. This one is plus 3 cos theta. Then we have our y. Then here, so cos minus 180 times this, that gives us 0. This one, sine minus 135 multiplied by 2. Then we have minus 1.01. The next one is sine minus 90 times 2. That will give us minus 2. And next one is